Welcome to part 2 of lesson 5.5, where the objective is that we are solving quadratic functions. In part 1, we looked at solving them by taking square roots, but it is absolutely the easiest way to do it. Why can't we just do it like that for all of them? Well, that method does not work when you have a linear term. So if you have a 10x or anything with a variable, just a linear variable, you cannot use the method that we just did. So we need an alternate, or we need many alternatives. This is one of them. So more often than not, you're going to need to use another method than what we just did. So again, that is a great method for the solving by square roots is a great method when the equation allows it. But for example, example 2 does not. So we're going to use what's called the zero product property. The zero product property states that if A times B equals 0, then either A is 0 or B is 0. You can't multiply two numbers together and get 0 unless one or both of them is 0. So what that means is if I can turn this expression into something multiplied by something else, I can guarantee that one of those is equal to 0. So what we're going to do, in order to turn this expression into something multiplied by something else, I'm going to factor it. So when you see the term solve it with zero product property, that means factoring. Okay, so we're going to factor this the way that we learned how to factor last lesson. There is no GCF between those three terms. There are three terms. So I'm looking, is there a coefficient up front? There is not. So I'm just going to unfoil it. So x goes here and x goes here. Since they're both plus, these are both plus. And now it multiplies 25 and adds to 10, and it is 5. So now you take both, and normally they're not going to be the same. So in this case, they are the same. But then you just take each one separately and set it equal to 0. So in this case, they're the same, but I'm setting them equal to 0 and solving now this linear equation. So just subtract 5 to the other side. So x is equal to -5 in both cases. So really, for this specific example, you just have the answer is x is equal to -5. If they were different answers on both sides, then you'd have two answers. So remember, think about it. We talk about how sometimes a quadratic equation can have two answers. Sometimes it can have one, or sometimes it has 0 real answers. This situation where it has 1. We got a couple more examples over here. Zero product property only works when you set the equation equal to 0. So we didn't have to do this in the last one, but we do for this one. We are going to subtract 18 to the other side. Again, zero product property only works if you set the equation equal to 0. Now I'm going to factor what's on the left side. Again, no GCF. There are three terms. So between those, I'm just going to unfoil it because there is no leading coefficient there. So x squared means I go x here, x here. The fact that I'm multiplying to a negative means signs are opposites. What multiplies to -18 and adds to +7? Again, make a t-chart if you need to find those factor pairs. If you can get it off the top of your head, that's great. This one, multiplying to -18 is going to be 9 and -2. The reason why the 9 goes with the positive and the 2 goes with the negative is because it has to add to +7. Now you set each of your factors equal to 0. So x plus 9 equals 0 means I subtract 9. You get x equal to -9. X minus 2 equal to 0. I'm going to add 2, and I get x is equal to 2. So when you write your answer, you're going to say x is equal to 2 or -9. Just put a comma. That's fine. You can write the word "or" if you want it, because it can't be both at the same time. But so that your two answers are 2 and -9. All right. Let's take a look at part C. Again, not equal to 0, so I'm going to subtract 8x from both sides. So you have 16x squared minus 8x. Is there a GCF? Yes, there is. Between 16 and 8, you can divide an 8 away. Between x squared and x, you can divide an x away. 16x squared divided by 8x is 2x. 8x divided by 8x is 1. All right, now I ask myself, well, how many terms are there? There are 2 left. You don't worry about the GCF for this part. It's just what's on the inside now. There's 2 terms. So the only question I ask myself is this a difference of squares? And it's not. 2x is not a square. So there's nothing else to do. So I'm done factoring it. I'm going to set my factors equal to 0. That 8x, that's just one term. I set that equal to 0 just the same. 2x minus 1, I will set equal to 0. Divide by 8 and you get x is equal to 0. That's one of your answers. So don't ignore that. Here I'm going to add 1. I get 2x is equal to 1. Divide by 2, I get x is equal to 1/2. So those are my 2 answers. X is equal to 0 or 1/2. All right, so those are your 2 answers. Last one here. Too far. Everything is already set equal to 0, so I don't have to do what I had to do in the last 2. There's no GCF between 3, 20, and 7. So I can't take a GCF out and look how many terms there are. There's 3. There is a leading coefficient. It's not a perfect square trinomial because 3 is not a perfect square. So I'm doing Mudd's method. All right, so I'm taking that 3, multiplying it over. You get x squared minus 20x minus 21. Now I'm going to unfoil. So x goes here and here. Multiplying to a negative, so go opposite signs. What multiplies to negative 21 and adds to negative 20? I'm going to put negative 21 here and 1 here. Again, make a chart if you need to make a chart to find that pair. Because 1 times negative 21 is negative 21. 1 minus 21 is negative 20. Now I'm setting those equal to 0 and solving. So here I subtract 1, I get x equal to negative 1. Wait, no. I should probably just stop the video, but I apologize. I'm messing it up. All right, ignore what I just said for the last, I don't know, minute. We need to finish factoring. So I'm not done Mudd's method. I jumped it. All right. Back to this part. Now the 3 I have to put back on. So I have 3x plus 1 and 3x minus 21. Now you divide a common factor where you can. Between 3 and 1, nothing. Between 3 and 21, I can divide a 3. So you got 3x plus 1 times x minus 7. Set those equal to 0. So 3x plus 1 equal to 0. Subtract 1. Divide by 3. Here you have x minus 7. Just add 7. All right. So those are your 2 answers, negative 1/3 and 7. All right. So that's how to do it. We kind of went through each different type of factoring. So the only thing that's different is the different type of factoring you have to do. The goal here is get everything to one side. So set it equal to 0, factor it as far as it goes, take the factor, set them equal to 0. Those are your answers. So that's the process here, and that's what you're going to practice. All right. So let me know if you have questions. We'll do an exit ticket on this on Tuesday. Tuesday because we don't have school Monday. All right. Let me know if you have questions.